Okay, all right, thank you. All right, next team. Just remember, 7 minutes, not 10 minutes, 7 minutes. Okay, go when you're ready.
All right. Hi everyone, we are Team 2, and we are the creators of Robbie the Robot, who is your smart companion. All right, so to introduce this project, we were inspired by BB-8, the droid from Star Wars, and we wanted to make him into a companion, kind of like Alexa, where you can talk to it, and it'll give you a response based off of a chat GPT output. So we designed this when you would talk to it. It uses voice recognition software based on many models to hear your voice and convert to text. Then it will be trained through a hybrid GPT model and output a text-to-speech algorithm. Finally, it has a camera on top that will actually detect your face and point towards wherever your face is to be in the center. The components we're using are the ESP32 S2 for the body, an Arduino Nano 33 camera on top, 2 servo motors on the side with wheels, LiPo battery, miscellaneous parts, and then we have a remote control that is uploaded on your phone through a web server. So move him.
So this is how Robbie rolls. So there's a different two-wheel differential drive robot inside a hollow ball, and when the wheels of the differential drive rotates, it sends a backward force on the ball, and if the weight of the differential drive is heavy, then the ball rotates ahead instead of the differential drive rotating inside, just like that guy here. And for the servo, we have magnets. And this is the device communication diagram. We have 3 main parts. One is the laptop, one is the head, and one is the body. And the communication happens using WebSockets, which is faster than using HTTP protocols. The body sends in the servo angles to the laptop, and this laptop sends back this, the change in the servo angles needed. And the head sends in the camera images as well as the audio input, whereas the Python scripts, they send back the trigger and the audio output back. And this is the first part, which is the face recognition. And in here, what happens is, first we receive the camera images from the head, and we see if a face is being detected or not using Har Cascade classifier. Har Cascades doesn't use any training as such, and it's like a predefined thing. And once a face is detected, it performs 2 operations simultaneously. One, it draws a bounding box and calculates the horizontal distance to convert it to servo angles and sends it back to the body for the change to happen. And second part is it sends an audio trigger back to start the audio display.
I'm going to talk about the chatbot. We've implemented a hybrid chatbot which has 2 parts, the dialogue GPT and the custom GPT. We did this so that we get a more customized output. Coming to the dialogue GPT, it is a pre-trained model by OpenAI. We've used the Hugging Face model to design and incorporate the GPT into our chatbot. It has a conversational capability to it, which makes it more efficient in the chatbot. The next part is the custom chatbot. We've trained it on a number of intents and is trained using a neural network. This would help us give us a more streamlined output rather than giving just a general response. Coming to the response generation, once the input is received, we can get 2 responses, which is from the GPT and the custom chatbot. This is going to gonna send the responses to the sentiment analysis and the confidence calculations, where both the responses are compared and the best response is given out. So I have two examples here. The first one, the dialogue bot and the custom bot responses are compared, and the custom bot response is given as the best response. Coming to the second one, the dialogue GPT has like the best response for the example here.
I'm going to talk about the custom chatbot results, and our chatbot model accuracy is around 98.85%. And as you can see in this confusion matrix, the bottom is the predictor labels, and the left part is our actual labels. And our models are trained very well, so the entities are in diagonal. And in the right side is our model accuracy, and we use 200 epochs, and it's gradually increasing and it settles. For the text-to-speech part, we put the chatbot as an input, and we use the library called GTTS, which is a Google Translate text-to-speech. And in the codes, we could change the language and the speed of the voice, and also we could select which gender we want, and it converts to a raw audio MP3 file, and we could conversate back to back.
So here's a short video of Robbie in action. When Robbie stops rolling, its head starts to rotate to detect the person's face, like it has on the left-hand video. When it detects the person's face, it starts listening to them. It takes in the user commands and gives out a response generated by the ChatGPT module. So you can have a normal conversation with Robbie. Here's a demo of the conversation.
How are you?
I'm good. How are you?
Have you been to Aspen?
I have not. I'm not sure if it works.
You should go for Loki and Hair.
I'm not sure if I should go to Lightyear or
Are you friends with Loki?
I'm not.
Who is a Yoda?
Alright. I hope you guys liked our demonstration.
Any questions?
Is partial up. Did you make it part of the presentation?
Yeah.
Okay, gotcha. I really like this. This is one of my favorites. Good job. I don't have any questions except can I have it? Any other questions? All right. Good job. Thank you.